All right. All right, so we're being asked to factor the polynomial x squared plus 4x plus 49. First, let's look at this other polynomial that I've written over here. Whenever we factor a polynomial, the first thing we should do is check for a GCF, check for a greatest common factor that goes into all three terms. So notice 2x squared plus 14x plus 20, there is a GCF. There's a GCF of 2. I can factor that 2 out. After factoring the 2 out, it leaves me with x squared plus 7x plus 10. And now I'm faced with a trinomial. The leading term of the trinomial is 1, right? There's a 1 right here. So in order to factor this, I need to identify two numbers that multiply to the number on the end, but add to the number in the middle. And the numbers here are 2 and 5, right? 2 times 5 is 10, but 2 plus 5 is 7. Once I've identified the correct two numbers, I can then factor the trinomial into two binomials, and those are x plus 2 and x plus 5. If I wanted to verify my factoring, I could multiply x plus 2 and x plus 5 back together. I could FOIL them. And if I multiplied x plus 2 times x plus 5, I would see that I get right back to x squared plus 7x plus 10. And the 2 on the front, we just bring that down. So this right here would be the factored result. You know, that's the complete factorization of this trinomial. Now, sometimes a trinomial isn't factorable. If a trinomial is not factorable, we call that a prime polynomial. So if we look up the trinomial that we have over here, and notice that first of all, there's no GCF. There is no term that goes into all three of the terms evenly. So this polynomial does not have a GCF. If there was a GCF, then that means I could factor it a little bit, and it wouldn't be prime. But there is no GCF, right? The next thing I try to do is I see if I can factor this trinomial into two binomials. The leading term is once again 1. There's a 1 in front of the x squared. So in order to factor this, I would need to identify two numbers that multiply to 49 but add 4. But the thing is there are none. So what numbers multiply to 49? Well, there's 7 and 7, but those numbers do not add to 4. Of course, we could have -7 and -7, but those numbers don't add to 4. 49 and 1 multiply to 49, but they don't add to 4. And those two numbers do not add to 4. There are no numbers that multiply to 49 and add to 4. So this trinomial is not factorable. Therefore it's prime. Right, here they want me to factor another polynomial. Notice this polynomial does not have a GCF. Any polynomial I ever try to factor, it's always good to check for a GCF. So there is nothing in common between x cubed and 8, so no GCF. This is a special binomial. It's called a difference of two cubes. Right? X cubed is the, here I'm going to write this bigger. We have x cubed minus 8. X cubed is the cube of x, and 8 is the cube of 2. Once I've identified what each term is the cube of, we can then factor it. And the general guideline for factoring a difference of two cubes is like this. If we have a cubed minus b cubed, that would factor into a minus b times a squared plus ab plus b squared. If we had a sum of two cubes, a cubed plus b cubed, it would be similar, just a couple of signs would be different. It'd be a plus b times a squared minus ab plus b squared. So when we factor difference of two cubes, the way it works is or sum of two cubes, either one, we identify what each term is the cube of, so like a cubed is the cube of a and b cubed is the cube of b. Once I identify what each term is the cube of, then we just plug them in appropriately into the spots. And it's just a matter of remembering how this factorization goes. You know, the binomial, all you do is insert the a and the b, and notice that the sign here is the same as the original sign that goes with both of these. And then the next sign is always opposite of what the original sign is. This sign right here is always the opposite of the original sign. And the last sign is always a plus. And after practicing factoring cubes a few times, we may start, find that we just remember this factorization. It looks overwhelming at first, but it takes some practice. And after we factor cubes a couple of times, and maybe refer back to this formula, if you want to call it that, we eventually find that we may remember it. And if we, after factoring a polynomial, after factoring a difference or sum of two cubes, if we wanted to check our answer, again, we would multiply these two polynomials back together to check our answer. All right, so I've identified what each term is the cube of. X cubed is the cube of x, 8 is the cube of 2. So the x is sort of like the a and the 2 is the b. So this is going to be x minus 2, it's 8 minus b. And then the first term is the square of a. So if you look at the formula over here, the first term is the square of a, so that's going to be x squared. The next term is the product of the two terms, the a and the b. So it'll be 2x. And the sign that goes right there is always the opposite sign that's in the original problem. And then on the end we put the square root of b, the square root of 2, so that'll be a 4. And that's it. So it's just a matter of remembering the factorization formula. If we wanted to check our answer, we would need to multiply the two polynomials back together. So we have x minus 2 times x squared plus 2x plus 4. So I'm going to multiply these together. So first we have to distribute the x. So that would be x times x squared, that's x cubed, and then plus 2x squared plus 4x. And now we distribute the negative 2. So that'd be minus 2x squared minus 4x, and then the negative 2 times the 4 is negative 8. But notice that we have some terms that cancel out, and the terms that are left are the x cubed minus 8. So that's right back to what we started with. That confirms that our answer is correct.